All right, so now that we've talked a little bit about generics in TypeScript, the next thing that we're going to cover is something called mapped types. So mapped types are used in a wide variety of situations, but the basic idea here is that if we have a type that we've either defined using an interface or a type that we've defined, like we defined this person type here, right, by saying type person and then defining all of the properties in sort of an object notation like we did here, there are actually a fair number of situations where we might want to apply some sort of logic to all of the properties in this new type that we created. So in order to demonstrate this for you a little bit, what we're going to do is I'm just going to create a new file inside our source directory here, and we'll call this mappedtypes.ts. And inside here, let's define a new type similar to the person type that we created earlier. But this time what we're going to do is we're going to say type, and we'll call this new type user. Now this user type is going to have a variety of different properties. It might have like a name property, and that would be a string. It might have an email property, and that might be a string as well. And it would probably also have an ID property that would be a unique identifier for this user. And maybe we'll also have an age property as well. All right, so similar properties to the person type that we defined earlier, but this is just a new example. All right, so with this user type, if we wanted to use TypeScript to create some sort of web server, some sort of REST API for managing users in a full stack application, you can probably imagine that there'd be a fair number of situations where we wouldn't want to exactly use this user type, but something very similar to it. So in order to understand what I mean with this, let's imagine that we want to create an endpoint on this API that allows users to submit information to create a new user. Well, it probably wouldn't include this ID type because that's almost always something that we want to generate on this server, right? Just to make sure that we have full control over those IDs so that they don't conflict. All right, so in that case, what we'd probably want to do is define another type that's similar to this user type, but without the ID property, right? So we might want to say something like type user data or something like that. And we might even want to call it like new user data, since this would represent the data that new users would submit in order to create an account, let's say. All right, and this would just contain name, string, email, string, and age would be a number. All right, so as you can see, these two types are very similar. Really, the only difference is this ID property. Now, in case you're trying to think of ways already to reduce the amount of repetition in our code, which is always a good idea, you might be wondering, wouldn't it just be possible to make this ID optional, right? Couldn't we just say ID with a question mark after it and have that cover both of the situations? Well, the answer to that is possibly, right? That might work because that could solve some of the typing conflicts that you might run into by having the payload that's coming to your server not have an ID, but having actual user data have an ID. But in this case, we would probably want to be more explicit, right? Because in our case here, users would have to have an ID, and we would definitely not want the user data that's coming in from the client side to have an ID. All right, so in this case, it's probably better to just have two separate types, but that doesn't solve our problem of having all of this repeated code, right? So here's where mapped types come in. TypeScript actually provides a variety of different mapped types that build off of the generic concepts that we talked about earlier. Let me just open that up here again, right? So they build off of the concept of being able to pass in types as sort of arguments using these triangle braces as we saw earlier. But what they allow us to do are things like get a subset of properties from a new type that we've defined, and that would be perfect for this situation here. So just to give you an idea of what that might look like, instead of defining an entirely new type, as we've done with our new user data thing here for this situation, what we could do instead is use a mapped type that's provided for us by TypeScript called pick. Now, the way that this pick mapped type works in TypeScript is we use triangle braces like this, and we can pass a type to this, right, such as user, and then after that we can put a comma and we can specify the exact properties that we want to get from this user type. So in our case, that would be name, email, and age. So what that would look like is we could say name, and then we're just going to use a single pipe symbol here, right? So name, email, and age, like so. Okay, and what this would do is it would have the same result as that new type that we defined previously, right, where we actually wrote out name, email, and age. But now the name, email, and age properties of this new type that we're defining, called new user data, are going to be exactly the same as the name, email, and age properties in our user type. So what that means is if we try and create a new user data instance here by saying let new user data, and we'll give that the type of new user data, of course. Well, what we can do is we can give this a name, so we'll say Sean. We can give this an email, so we'll say sean@email.com, and we can say age, and we'll say 123, right? And we'll see that that will work perfectly. All right, so in the situation that I've been describing here, this would be, in theory, the data that would come in from the client side. And then if we wanted to add an ID, what we could do is we could say let new user equals, and then we could just take all of the new user data using the spread operator, and we could add an ID property like this just by saying something like ABC123. Okay, and as you can see, if we now add the user type onto this, TypeScript will say that's perfectly fine, right? Because now this new user object has all of the properties from new user data, right? So name, email, and age, as well as this ID property. So anyway, this pick type is just one of several mapped types that's available to us in TypeScript for different situations. Another mapped type is the read-only mapped type, and basically what that does is it creates a version of this new type where none of the properties can be edited. All right, so if we were to say something like type and call this a constant person or a constant user or something like that, we could just say equals read-only user. And this read-only type, by the way, that should have a lowercase o, right? So read-only is one word here. And read-only doesn't take any extra arguments in its triangle braces like the pick mapped type did, right? So for read-only, all we have to do is pass a generic type to it. And now if we create a constant user, right? So if we say something like let user equals, and actually here, let's give it a type here of constant user. If we assign it some properties, so we'll give it an ID, we'll give it a name, so we'll just say Sean here, and there we go. We'll give it an email, so sean@email.com, and an age, 123. And now we see that that's perfectly fine, but if we now try and change one of these properties, right? If we try and say user.id equals 234, well, TypeScript's going to complain about that because, as we see here, it says cannot assign to ID because it's a read-only property. So basically what this read-only mapped type does is it takes all of the properties in a new type that we've defined, like this user type, and it adds the read-only keyword to them. And by the way, in case you haven't seen the read-only keyword yet, I don't believe I've talked about it at this point, the read-only keyword is sort of similar to what we were able to do by making properties optional, right? Where we were able to add a question mark after a property name, and that would make it so that TypeScript didn't demand that we had that property on this object. The read-only property is sort of similar, where we add that onto the property name, and in the case of the read-only keyword, we add that before the property name. And what that does is it basically makes it so that once that property is set on an object of this type, it can't be changed, as you can see down here. So what the read-only mapped type does is it basically takes all of the properties in a regular custom type that we've defined, such as this user, and it automatically adds read-only to all of them, right? So basically the effect that it has is if we were to go through and just add read-only to all of these properties, right? Read-only, read-only, read-only. That's the effect that this read-only mapped type is going to have. Now, in case you're wondering if there's also a mapped type for making all of the properties in a custom defined type optional, right? So if there's a mapped type that goes through and just adds a question mark to all of these properties for us, the answer to that is yes. And the mapped type for that is called partial. So if we wanted to create a version of this custom user type where all of the properties are optional, what that would look like is we could say type partial user equals, and then we would say partial and pass the user type as the generic type to that. And now what we can do is we can say something like let partial user. And if we specify partial user as the type for this, then what TypeScript will let us do is include any of the properties that were in this user type. So if we add something like an ID, TypeScript is perfectly fine with that. But if we leave some of the properties off, it's fine with that as well. And if we try and add a new property that isn't under this user type, right, such as favorite color, right? TypeScript doesn't like that because that's not one of the properties that's available on user. Okay, so those are just 3 of the common mapped types that TypeScript provides for us. And as you can see, they really make the process of manipulating custom types that we create much easier. And they allow us to do things like get a subset of the properties that a type contains, get a version of that type where all of the properties are read-only, and it allows us to get a version of that type where all of the properties are optional. All right, so these are just a few of the many mapped types that TypeScript provides, but as we've seen, they can actually be very useful.